Hey guys, how you doing? This is Coach Scott, and let's do another Purple Wave Chemistry. Okay, so this is a review video of Unit 8, the mole conversions, and we're gonna hopefully just tie everything up. I've got lots of videos that you need to watch before we take the test. It's already on YouTube, already in Teams. But let's look at this. Let's just tie some things up. So again, one of the basics of this is, well, okay, what's a mole? Okay, a mole is a unit of measurement, a unit of measure of how many, right? And how do we convert things into moles? We've got to have the number of atoms, the number of molecules, the number of particles that are going to act with it. So this is pretty important. So I gave you all a little map. This little n, that's what we use to represent moles. Little n. Little n, I'm going to put it even up here. Little n equal number of moles. All right, number of moles. And then I like using this little thing. This is, some people call it the mole island. But let's say we have, let's just say we have um, uh, the number of moles, and we want to know the number of particles, the total number of particles. Well, we use something, and it's a special number, and of course I'll give it to you for a test. It's Avogadro's number, Na. All right. So what we're going to do, if we're given the number of particles, let's say 1.2 times 10 to the minus 24th, that's a big number, right? So N equal number of particles. All right, and this is a measurement sort of like, if I have 12 eggs, that means I have a dozen. If I have 6.02, which is Avogadro's number, all right, Na equals 6.02 times 10 to the 23rd. And that's just a counting number. All right, big number. But let's say I have 1.2 times 10 to the 24th. I divide that. I don't know what's going on here. Ooh, okay, yeah, my screen went sort of crazy. I think I got a wire on my keyboard. Hang on. All right. So anyway, I would divide that by 6.02 times 10 to the 23rd, which means I'd have that many moles, 2 moles. All right. So let's say we're doing molar mass, right? So I got a little arrow here. Okay, and another little arrow here. Molar mass. Now this is similar. I'm going to have M for our sample mass. M is sample mass. All right, we can get that with a scale. All right, it's given to you, sample mass. All right, if we divide by the molar mass, that's a capital M right there. Capital M is the molar mass, which we get from the periodic table. Molar mass. And I think you guys know how to calculate molar mass now, but we look at the atomic mass, and if there's 2 carbons, we take that 12, multiply by 2. If we're talking about carbon dioxide, 1 carbon is 12 grams, and you've got 2 oxygens, 16. 16 times 2 is 32. 32 plus 12 is 44 grams per mole. So that's where we get that, from the periodic table. The other way that we can find moles, if we have molar volume. All right, molar volume. All right, and that's pretty easy. So we'll use our big V. That's our sample volume. You either measure that, or this is for gas. So you either measure it, or it's given to you in a problem, and you're going to divide by the molar volume. Now Vm is always the same at STP, standard temperature and pressure. It is 22.4 liters per mole. That's what you need to do well on these problems, right? Another thing we're going to cover on the test is percent composition. We went over that pretty good, which is where the mass or the mass of the component is divided by the mass of the total compound, right? So let's look at some things here, right? Let's see. I've got a chemist collects 44.8 liters, right? Liters of a gas at STP with a molar mass of 44 gram. First question, how many moles of a gas are present? Well, I've got a sample volume of right there, 44.8. That would be my big M, liters. Then I'm going to divide by the molar volumes, 22.4 liters per mole. Well, I can do that pretty much in my head. So that's 2 moles. 2 moles of gas. Okay, cool. All right, if the gas is 27% carbon by mass, how many grams of carbon are in the sample? Okay. Well, I've got 2 moles, and it told me here that the molar mass for 1 mole is 44 grams. I've got 2 moles. 2 moles. So 44 times 2, that would give me my mass of the sample, 44 grams per mole times 2 moles. That's going to be 88 grams. That's what it's supposed to be. Now, it says the mass of the percent carbon by mass is 27.7. So I ask how many grams of carbon are in the sample. Well, the mass of that sample is 88 grams. So all I got to do is multiply by 0.2777. 0.2777. The percentage, so the percentage of carbon in that sample would be, let's see, 88 times 0.277 equals 24.376. Well, I want grams. I want good sig figs. That's got 3 significant figures. Let's do that. 24.4 grams of carbon. Got this. So, what might this gas be? Well, let's see. 44 grams per mole. Let's assume, all right, because I know that carbon dioxide has a mass of 44 grams per mole. Let's assume it's CO2. Let's see if this makes sense. So, carbon would be 12, and I got 1 carbon. Then I've got 2 oxygens, so that'd be 16 times 2. That's going to be 32. Let's see if our percentages are right. So if I add all that up, I've got 44 grams per mole. Let's see if we take 12 divided by 44. That gave me 27.3%. That was a pretty good guess. All right. And that's pretty much how you could answer one of those type questions. And I don't think you'll see anything too major or too wrong on that one. So anyway, that worked out. All right, 32% of oxygen would be, let's see, 72.7%. So I could assume pretty easily that that's going to be CO2. All right, so we can get through that pretty good. Now, another thing we're going to be assessing on is your knowledge of how to do an empirical formula. All right, here's a compound, 4.2 grams of nitrogen, 1.2 grams of hydrogen, and 4.8 grams of oxygen. Well, how do we get the empirical formula? Well, we got to calculate. So I've got grams. I don't have to do the percentage thing, that little magic with the percentage. I know what it is of nitrogen. All right, I got 1.2 grams of hydrogen. And I got 4.8 grams of oxygen. So first of all, I've got to get the number of moles. So I'm going to divide by the molar mass. So nitrogen is 14, 1.01, that's close. Then hydrogen, 1 mole over 1.01 grams. grams. And then oxygen, we'll just use 16, 1 mole, divided by 16.0 grams. And that'll give me my number of moles. 4.2 divided by 14.01. And I got, well, really, if I round everything up, I've got 0.3 moles. Then 1.2 divided by 1.01, I get 1.2 divided by, yep, I get 1.2 moles. And then if I get 4.8, divide it by the molar mass, 16, I get 4.8 divided by 16, I get what? 0.3 moles. Now, I'm going to find my least amount of moles of any of these that I've got, and it's 0.3. I'm going to divide everything by 0.3, that by 0.3, of course that by 0.3, because I want to get these into as much as I can whole numbers. That's going to be 1. That's going to be 4. That's going to be 1. So that gives me my empirical formula. And it would be, let's see, N, or N1, H4, and O1, or just O. So NH4O. Okay, that's cool. So we also need to know how to find the molecular formula. That's pretty, you got to know it. So it gave us the actual molar mass of the molecular formula is 94 grams per mole. So first thing we got to do is take the empirical formula mass, NH4O. So let's get that. So nitrogen has a mass of 14. Hydrogen has a mass of 1. There's 4 of those, so I'm just going to add 4. And then oxygen, 1 oxygen, it has a mass of 16. So I get 34 grams per mole. That's the empirical formula mass. So if I divide the molecular mass, 94 grams, that's where I got it. They gave it to me. All right. Either one, I used an experiment and got it, or they're going to give it to you, which will give it to you in a problem. All right. And that's divided by the empirical formula mass. And that'll give me a factor. 94 divided by 34, and that gave me a factor of 3. We're going to call that 3. That gave me a factor of 3. 2.76. That's going to be one that I can actually round up. Okay. So I've got 3. So now I'm going to take that 3, that factor, and I'm going to multiply it by my empirical formula. Like so. So that would be N3, H12, O3. So that would be my molecular formula of this particular compound. N3, H12, O3. And I got this from using the molecular mass of the molecular formula, which was given to me in the problem. They don't give it to you. You can't find it from the periodic table. They have to give it to you. So anyway, guys, this is a pretty good review. I think if you do this and go back and watch the other questions, do some problems, you'll do very well on the assessment. So this is Coach Scott saying, Hullabaloo, Knick, Knick.